Um, Good afternoon, all. I am Smita. Welcome all of you on session 2, on which is the last session of last day of IST AICTE approved refresher program of developing secure IoT application. I am glad to introduce you the session speaker, Mr. Jeetendra Shenoy, sir. Sir is IoT architect in LTI. Sir has over 22 years of experience in the digital space. Sir built and developed large-scale application in the area of embedded and open system. The topic of the session is role of IoT in new digital age. I request sir to start the session. Over to you, sir.
Thank you, Smita, and thank you all for giving me an opportunity to present to an audience of teachers and professors they build the next generation. So it's my great pleasure to have this talk. Feel free to ask any questions if there are any. Um, so I'll move on to the topic. I'll try to present. If it doesn't work, then I think you guys will have to present like last time. I've already mailed it to that email ID. Yeah, thanks.
Yes, sir, it is visible.
Yeah. Okay, it's from my side or it's from your side?
Sir, from you, our side, sir.
Okay, because I see only
Dhanikesh, sir,
half.
you are displaying now.
Yes, ma'am.
Yeah, okay.
It's from our side, sir.
Yeah, no problem. Okay, only thing is I'm seeing half the screen. Okay, wait, give me one sec. This is a problem in Teams. Okay, so we'll talk about role of IoT in this new digital age. So already I think for an week, a lot of IoT related stuff was bombarded, right? So right from how to implement it on device, so how to put it onto cloud, what are the different security, the protocols and all that stuff. So what I'll do is I'll actually view together everything which was done in IoT and we'll look at what is the way forward and how industry is going forward and what are the drivers. Okay, so main thing is we'll see how IoT will play a major role in the coming future. Okay, so we'll go on to the agenda, the next slide. So in this agenda, I'll talk about what is digital age, how it is impacting and how it has already started. Then we'll look at, sorry, sorry, we'll look at all the building blocks which are necessary. Most of it will be technological building blocks. I'll talk about. There are socio-economic factors also which are driving these building blocks. Then we'll look at what is the way forward and how it's going to impact our lives. Okay, so we'll move on to the next slide. Okay, so what is the digital age? So if you look at the current age is age of Aquarius. So Aquarius is like a man. If you look at the symbol, it's a man with a pitcher and there is water flowing out of the pitcher. So it's not actually the water. It's like in earlier mythological age, if you look at it, it is described something which is similar to electrons. Okay. So if you look at last 50 years, it is like tremendous improvement in the digital age. Okay. So like way in 70s, like you had radio, television and all those things, television coming in India and so on, right? We had Asian Games, the first Asian Games, whoever like I think in 40s or 50s, they will remember like, so at that time we jumped into like the digital age. So earlier, like if you look at banking system, we had tellers where you have to go to the bank, give your check, self-signed check, and then a token will be given to you. Okay, at that you have to sit for some time, and that check will be passed on to two or three different personals in the bank. They will verify your signature, and then your token number will be called in the cashier counter, and there you can collect your cash. But nowadays, if you look, you have a plastic card in your pocket, you just go to a machine and just withdraw the cash, right? So all that verification, everything has gone digital. Whatever people who were there earlier in that process have all gone away. Those jobs have gone away, and it's like you are interfacing with a machine to get your job done. Now, in this age of Aquarius, it means that old way goes to a new way. Means it's not there is an improvement on the old way, but it will be totally moved on to a new way. So it is disruptive. Now, what do we mean by disruptive? So we have to understand this very carefully because this is going to impact our life. If we take an example of an mosquito coil, right? So Kachua or like whatever brands were there earlier, okay? They have gone nowadays and you have hit or something like that, right? Those things have become very prevalent. So if you look at the manufacturing or way it was built, it was totally different. And the way this hit or like these can based, gas based sprays which you get is totally different. So whatever manufacturing technology or whatever skills you had in the older technology is nowhere relevant. So it's going to be all disruptive. Exponential progress in digital areas. So it is going to be mind-boggling progress. So that's why it is I have written exponential. So we'll look at some of the progresses which already happened and which is going to happen down the line. And it's going to have a huge impact on business as well as on society. Now, whenever there are business drivers, okay, positive in terms of a change, it's going to get implemented. And this is going to get implemented and it's going to impact society. So even if people protest or do like they are against it, but there are enough drivers such that it will go towards it. Now, what McKinsey suggests is that 80 million people could lose their job to automation by 2030. So this is a huge number. Okay, so we have 7 billion. So 80 million is near to like 1 billion. So one one upon seven. Okay, so that kind of job loss might happen. And out of those 7 billion, not all of them are in the category of holding jobs. Okay, so we'll move on to the next slide. Digital transformation. Now, in which all areas it has affected. Now, energy. Okay, energy has become smart. Now, what do we mean smart? Okay, in India it is bit slow, but it will also pick up. Okay, now in smart grid, what happens is there is an intelligence which can talk back to the grid, and when there is surplus, it can communicate and it can tell you that there is surplus in the grid. So how this can impact? Okay, now how does surplus happen? Okay, let us look at hydropower or some power, okay, or solar power or any other power. So what is power? Power is nothing but a differential voltage created across two ends, right? So whether you consume it or you don't consume it, okay. So hydropower, if you are generating X number of megawatts and if it is not getting consumed, it's gone. It is for that instant. You cannot store huge amount of energy. We have not reached that stage where we can store huge amount of energy. Okay, there are a lot of research happening in molten salts and other areas, but it's going to take time. Lithium ion batteries, hydrogen fuel cells, and so on. But it's going to take time where we can store huge amount of energy. So the energy is lost if it is not consumed at the instance which is created. So what these energy companies do is they convert their grid into smart grid where the appliances can talk to the grid and they can have differential metering. Now, what is differential metering? When there is surplus, your per unit charge might drop and you can have equipment such washing machines or whatever such that you can program it to such a thing saying that okay, if the cost goes below X amount, it should start and do its job. Okay, so it will save energy consumption means the bill which you get at the same time it will use that energy which is going wasted, which is going to waste now. Okay, so smart grids are going to get very hot. Okay, renewable energy. Right now we solar, wind, and all those things. What we do is we just take the energy, but the grids will be such that you can pass this energy back to the grid and you can earn positive billing. Means you will earn money for the amount of energy which you pass on to the grid. Microgrids means self-independent grids which can be run in towns or in small villages, which is independent of the main grid. So are going to be hot down the line. In the areas of communication, again, you have like, I need not tell you, like on social media, like it is very hot, right? WhatsApp, you can just communicate to any person anywhere. Okay, there are people who communicate from one room to another using chat or WhatsApp, right? They don't just walk and talk. Okay, walk to the person and talk to the person. Virtual is like you will as if have that person physically present there. Means it can be a 3D hologram or it can be an virtual image. Okay, so those technologies is going to come in. Okay, transportation is another area where digital transformation has taken place, and in this area it is huge. Okay, like right from loading plan. Okay, what do I mean from loading plan? um, if you look at a ship or any transport vehicle, you want to optimize the usage of that vehicle. At the same time, there should be a plan. Like if you are going to do n number of stops and you are going to pick up and drop things, you cannot have the material which is going to be dropped recent in the first stop stacked somewhere very at the bottom, right? You will have to remove all the goods, then deliver it out. So you have to have a plan. Now, if it is a small tempo, it doesn't matter much, but if it is like huge ships, like the container ships, which has 7 layers under under the flatbed, which is you see, means inside the ship you have 7 layers of containers, and on top of the ship you have 7 layers. So that is total 14 layers of containers. And such kinds of layering, when it is there, you have to plan it very well, because per hour berth charges for these ships are like runs into lakhs of rupees. Like for an hour, it is more than a lakh for them to berth. So their aim is to have minimum time such that they have to spend on the berth such that they can finish their goods onloading and offloading. Okay, even the crane operators which are there, they are paid handsomely, because they have to do, I think, around 42 containers per hour. Like they have to move in and out from the ship. So that's kind of automation which is happening there. There are some robots, like if you look at ports in Germany and other places, there is no humans involved. It's all robots who just pick up the containers from the ship and move on to the dock, and from the dock moving on to the loading area. This was on the shipping side. Now, if you look at fleets means cargoes. Like you have big trailers which take your cargo, right? Means your vegetables and so on. Like in US, there are a lot of container trucks which take move around goods. Okay, so those goods, those fleets are huge in number. Okay, the amount of people moving is negligible in terms of the goods movements which happen. Now these fleets have to be optimized for the route optimization, for the fuel optimization, and so on. So at the same time, they are looking at driverless fleets where it can be a train of fleets. A train of fleets means a truck behind another truck, truck behind another truck, and all of them are getting driven without a driver. And there will be intelligence in the fleet such that they will know when to join that particular train and when to come out from that particular train. So these kinds of technologies have already come in, and these technologies are also um, taking means in defense this is heavily used. Okay, especially for missiles. We'll talk about those things when we go into the defense related area. Okay, so that's on transportation. Okay. Other than that, like you can have where is your truck, what is the fuel inside the truck, how much time the driver has spent driving the truck, like what is his driving profile, like how much he brakes, does he miss any red light and so on. So all that is captured. Okay, and it's already captured by the insurance companies and the insurance is decided based on that. So all this technology has already come in. On the finance side, we are seeing digital currency. Now, digital currency is becoming very hot because one of the example like is your credit card, right? Or NFC cards or any of these are all digital, right? You don't have anything, your physical notes or your gold coins or whatever, right? It's all in digital. Okay, it's an entry in the past in the bank digitally, and that's your amount, right? Tomorrow if somebody wipes it off, it's all gone. Okay. Then cryptocurrencies take help of bitcoins and it's a distributed ledger, and this is going to be hot, but there are a lot of regulations around how, because people misuse it because government has no control over cryptocurrency. So they are trying to um, have some control over it, but I think down the line cryptocurrency will be hot because if you look at China has brought in their own cryptocurrency. Okay. Now medical, in the fields of medical, you have virtual medical assistants already present. Means like you want a doctor, you generally go to an family doctor which is nearby, right? Instead of that, you will be going to your phone and just having a video conferencing with your virtual doctor, and the doctor can prescribe you the necessary medicines for your general illness. Okay, and if it is something which is serious, he can pass it on to some hospital or some actual diagnostic center. Okay, now this there is lot of medical transcriptions which happen, right? Medical transcription means a doctor when they tell the patient, okay, whatever the conversation happens, that has to be converted into transcript. Okay, so there is a lot of work which come from other countries to India for medical transcription. Now, once that data is present, it digitally analyzes the data, and you can have an bot which can automatically answer most of the general questions, and it can act like a medical assistant. Okay, so that's is an another area where it is like there is a lot of things which are happening. Then other areas are like virtual operations where you have multiple surgeons from different countries interact over an complicated operations. Um, and for these kinds of things to happen, you need an very reliable connections like 5G and so on with an fallback and everything. So these things will happen down the line. Okay. Smart manufacturing. Now, what is smart manufacturing? In smart manufacturing, the main aim of manufacturing is you should have just in time your assembly line should be just in time. Means you get an order, you get all the necessary goods just in time so that you don't have to keep them in warehouse. Your warehousing cost get low. Your plant, your equipment, your resources, your manpower, everything gets utilized to the fullest capacity. So in manufacturing, this is going to be huge. Now with 3D printing and all that stuff, okay, manufacturing is going to go through an overhaul. Okay, it won't be a standard stuff. As like if you look at humans, we have tendency to build like different models for the same thing. Like I'll give an example. Suppose most of you have cars, right? And if you have, suppose your headlamp is broken or headlight is broken, you cannot take any headlight and just put it in. You have to have that particular model of that particular manufacturer's headlight to just put it in. The job of the headlight is nothing but to give you light when there is dark, right, in front of your car. But we tend to do that of having different kinds, different models, and that brings in challenge in manufacturing and making spare parts. So digital printing, 3D printing in the digital world will play a huge role in these kinds of stuff. Okay. Next is agriculture. Agriculture is an backbone, and here we will require a lot of automation because whoever have farms, okay, most of their complaints is they don't get people to work on the farm because farm job is it's not an continuous 365 days job, right? Like you need people when you are harvesting, when you are sowing and so on. So it's like it peaks and it wanes. So in agriculture, a lot of automation is going to take place, and to feed 7 billion people, okay, we will have to take care of our food wastage, which is high right now because we do not have a good amount of like maintaining the food quality or produce quality in our supply chain, like freeze them in correct way, make the movements in correct way, avoid the damage when it is moving and so on, like when it is being picked up and so on. So a lot of food, like a lot of raw produce gets wasted, but that will be taken care of. Even then, we have to feed around 7 billion people. So down the line, okay, there will be an heavy pressure on the agriculture sector. Education is going to move virtual. What do I mean virtual? Okay, you must have seen Udemy or any other things, right? Okay, you will have a lot of courses there, right? If you look 30 years back, okay, there were like not many things on the net, right? It was just Netscape, and you had that green monitors, black and white monitors with one Netscape browser. Nobody thought that you will be having videos where people will explain you right from like how an engine works, aircraft engine works, to like how to cook a particular dish, right? Okay, so all that is moving virtual, and because it is virtual, people from any country can learn from any other person in any other country. So it's going to become flat. Okay, the world is going to become flat. So earlier, if you want to learn anything from some person who is well known in that field, you had to travel to that particular location where he teaches. But now you can have those lectures wherever you want. Like if you can have MIT lectures, you can have Harvard lectures, okay, on the net. Some of them are free. You can go and search for those links, and you can attend any of those courses. Okay, okay, moving on to the next slide. Okay, now we'll look at all the things which are present, like end user devices. Okay, so these are the things which will become backbones. Okay, 7 billion people, and according to Gartner, by 2020 there will be 20.8 billion devices. Okay, so if you look at one person, okay, he has smartwatches, phones, self-driving cars, television, baby stroller. Means there will be multiple devices around each person. Okay, so medical implants, so you name it, okay, it will be there. Okay, and these will be all connected to sensors, radio frequency identification, and near field technologies. Now, sensors will capture the data, okay, and it will be processed and passed to the actuators to actually do something. Okay, now identification, you have to identify which is the device and so on. So the radio frequency or RFID tags or near field communication, all these is going to become very hot. Okay, mobile phones and electronic devices and home appliances are going to get integrated. Okay, see, now if you look at your mobile phone, it is not just your phone, right? It has a camera, it has a radio, okay, it has a watch. Okay, other than you can talk and listen to people, you can do video calling, right? So you name it, all that thing is getting integrated in your mobile phone. Okay, you have applications where from your mobile phone you can do email, you can control, you have applications where you can Hello, I'm audible now?
Yes, sir. Yes, sir.
Okay, so what I was talking about was mobile phones. Okay, right. So that's where we had reached, right? So uh, so in mobile phones is going to play a major role because it's going to integrate everything. Okay, we'll move on to the next slide. Okay, storage. Now storage will be huge. Okay, the requirement will be huge. Okay, early in earlier days, storage was an hot commodity. Like I remember, I had taken, I think, like around 97 or something. So in those days, I had taken an 4 GB hard disk, 4 GB. Okay, and it was not the smaller one. It generally comes in big size, and I had paid 11,000 rupees. Okay, I remember that because I had paid cash for that 4 GB hard disk. So nowadays it is so cheap to get in terabytes. Okay, you get it in terabytes. Okay, now the amount of data which it gets generated, okay, is huge in whatever applications we have nowadays. Now, if you look at autonomous car, it will generate around 4,000 gigabytes. Okay, that is 4 TB data in just 8 hours of driving. Okay, because there will be so many of so many sensors and so on. Now, this kind of data, you have to have a network or a channel through which you can pass and you can parse. Okay, you have to parse that data and you have to take action in real time. Okay, like now, if you have a car and if it is running at 30 kilometers per hour, okay, and if you want to turn, that is fine. Like if you miss 1 or 2 seconds, right, and you if you adjust it, but even then you might go off a little from the lane. But if you are running at an 80 kilometers per hour, you cannot avoid have that mistake, right? You have to turn at the right time. Okay, so real time RTOSs like real time OSs are going to become very hot. Okay, so there, like even if there is an if you look at an any OS, there are a lot of housekeeping jobs, right? Okay, so in real time OSs, the job which is priority has to be first taken care first. Means priority means like I want to turn and it has to turn now, or I want to brake, I want to just brake now because I have a cow coming in front of the car. Okay, or the car in front of me suddenly braked. Okay, so these kinds of things will be required. Okay, so this amount of data has to be parsed. Okay, so if you divide by 8, you will have some 500 GB of data coming in per hour. Okay, that you divide by 60, you will get the amount of GBs in the amount of data in GBs which is going to work come in, and that you have to parse near real time. Okay, aircraft engines, like if you look at Boeing engines, okay, they monitor their engines even after like monitor their engines when they are sold to consumers. Okay, so that generates around 50 gig of data per hour in flight, and that is captured by Boeing and they give feedback to the companies who have brought their engine. Data capture, storage capacity and retrieval requirements will all need to grow exponentially. Now need to grow exponentially. Okay. Now if you look at our bandwidth right now, right? Okay, we have such an unreliable bandwidth, right? I dropped on from Steams, right? Okay. Now because today my broadband is down, I am on mobile network, right? It has some fixed amount of bandwidth. But if I want to do some application which takes around 50 gig of data per hour, okay, I'm not able to do it with this kind of a bandwidth, right? So our last mile has to change. Last mile has to have that much power. So the telecommunication companies are nowadays struggling actually to build bandwidth. Okay, so their main aim is to build bandwidth. So that's where their main focus is. Like, how can I get maximum bandwidth from whatever infrastructure is which is deployed, or what has to be deployed such that I can get the maximum bandwidth out of the infrastructure which is getting deployed. Okay, so we'll move on to the next one. Computation. Okay, computation are of multiple times. Real time means it has to be done at that time, means it has to be done at that time. Near real time is like there is a video which is happening, right? So if you lose one or two frame or it just comes out of order, you can adjust, because in video there are algorithms where it will take care of the delta between the two frames, right? So that is near real time data, and you have to process that kind of data. Parallel processing, if you have huge amount of data, there is no other option but to process parallelly. Okay, scale up and scale out. Okay, this will come in a lot. Okay, scale up is like you take the same machine and put in a lot of compute power, lot of memory, lot of storage, and try to take it take its specs higher and higher. So there is a limit, because your motherboard might say that, okay, I can handle only 4 CPUs with hexa-core each. Okay, so 4 into 6 cores. Okay, so that is 24 cores on one motherboard, and then the bus speed might be some X, and it might have some 256 gig of RAM, which is solid state, and so on. So scaling up is very costly, and there is a limit to it. Scale out is you take multiple low cost machines and you spread it across a farm, and then you use them for processing. Like suppose um, we want to have a website which will handle SSC results. Okay, so at that time you can scale out. You can have multiple instances of a normal desktop PCs which can spawn on cloud, and all of them can cater to the same website, and it will be a farm, means there will be a load balancer in the front and which will pass the request to these number of small machines which are sitting behind, and this is very cost effective. You can like bring up these instances very fast, and you can uh, spin down those instances also when it is not required. So cloud technology is going to become very hot in scale out. Okay, energy requirements. When you look at energy, all these things require energy. If you look at Google data center, okay, their motherboards are optimized in such a way such that, okay, if you look at a general motherboard, you have sound chip, you have other things, right, which are auxiliary. But in their motherboard, you will not see the sound chip. Why? Because the sound chip is not at all required. It will unnecessarily take the power, right? So for them, it is compute. So their motherboards are made in such a way such that it will just do the job of doing Google search. Okay, and that's how they save energy. They build containers of computes, means it will be a full container which will be having all these motherboards sitting, having RAM inside, the cooling inside, and it will be sealed. Okay, and they can drop ship it anywhere. So some of them are drop shipped in places where there is a lot of ice. In some cases it is under the sea for cooling, and so on. So they switch this whole block. If something goes wrong, they switch it and switch in and switch out this whole blocks. Okay, compute speed based on crystal frequency. See, your controller works on crystal, right? Like your megahertz. So bit processing, it depends on this crystal frequency. Sorry, crystal frequency is like the hertz, okay, like your heartbeat, and processing bits is the amount of data which you can parse at one shot. Like if it is an 8-bit processor, it will parse only 8 bits, but if it's 64-bit, you can process 64 bits of data at one shot in one machine cycle. Okay, so crystal frequency and processing bits. So the here the it will increase further and further, and nowadays I think DNA based processing is also coming in. So let us see what happens in the processing area. Okay, moving on to the next slide. Okay, network has to be ubiquitous, also known as means ubiquitous means it should be present everywhere and it should be very reliable. Okay, and the distribution of communication infrastructure and wireless technologies throughout the environment to enable continuous connectivity. So this is very important. It has to be continuously. Give me 1 second. I'll just see what this noise is. Hello. Sorry, there was some lift work going on. Okay. Hello. Can you guys hear me?
Yes, sir, you are audible.
Okay. Sorry. Okay. So we have to have continuous connectivity and it should be present everywhere. Okay. So ubiquitous means that. Okay. So network throughput and speed at the same time bandwidth and in order and out of order. Okay. We talked about in order is like we want to have packets coming in order like TCP. Out of order is like UDP where it's okay. Like if it comes out of order, you are transferring a file. But if you get out of order, you can rearrange those contents and you can store it. So um, you don't want them like in order right now. Okay, when you are storing, you are just storing it in the sequence. Okay, so out of order is okay. So the charges for in order and out of order will start differing. Okay, based on the bandwidth. Okay, we'll move on to the next one. Okay, security. Security is a very important factor. I think multiple sessions must have been on security, right? Because the whole topic was on security. So here I'll just touch on the security. So security is nothing but onion layers. Okay, so you always look at security from onion layers. So if you have any premise which is secure, you will have layers of security. So if you break one layer, you have another layer which you have to break with, then another layer, okay, and so on. So always remember security is layered. Then human factor, okay. The crucial piece in the security is human factor. That is the weakest link, okay. So chain is as strong as the weakest link. So humans are the weakest link. Like if you want to break any secure facility where nobody can it is very impossible for you to go and do something, like people will humans will be targeted in such cases. Okay, now the man and the dog story. Okay, here, okay, I'll explain. So suppose there is a factory which has everything automated. Okay, and you don't need anybody to touch it and make sure that it is running, it runs fine on its own. So then you have to have two of them. One is man and another is the dog. Okay. Now why do you need the dog? The dog is there to make sure that no man goes towards the system because it is running perfectly well on its own autonomously. Okay. But then why do you need the man? The man is required so that the dog is fed. Okay. So that's how the security will be down the line. Okay, embedded chips and POS terminals. Now, this is like you generally go and swipe your cards, right, on the POS terminal. Okay, or you do NFC, or you do, or that smart chip is red, right? The contact chip is red. Now, if somebody opens that POS terminal and writes and hooks in some sniffer, okay, or does some hardware stuff. Okay, then they can easily capture all your signals and they can rerun your signals, right? Okay, so the terminals are built in such a way such that moment it is opened, okay, the whole system will get wiped out and the chip will become useless. Okay, so such kinds of technology is going to come down the line because there will be a lot of devices which will be floating around you and which will um, impact lives. Okay, like it can be a medical transplant or an implant which is inside your body, or it can be something for your house security and so on. So currently, whatever technology is in there in the POS terminal, it will seep down into these kinds of devices. Okay. Now access to data will be key. Now, what do we mean by this? If you look at Google, okay, what does Google do? Google captures your data knowingly or unknowingly. Like we go to Google Maps and say, okay, I want to see where is the traffic, right? Now, how does Google get that traffic data, right? It has it just captures it from your mobile. Like there are so many Android mobiles which are in so many people's phone, right? And they are on the road and they see that how much time this Google phone is taking to move from place A to place B. Okay, so they collate that data and they say that, okay, there is a congestion on this portion of the road. Okay, same way, like if you look at any big voice, okay, they just capture your data, whether you are shopping on the net, whether you are doing any, whether you're surfing on the net, all that data is captured and based on that data, relative information is fed to you. Okay, so whether it is in terms of ad, whether it is in terms of whatever applications, or whether it is in terms of merchandise. Okay, so when you go on the data on the digital world, your footprint will always be there. So whether you swipe a card or whether you take a gas from some station or whether you uh, go anywhere, okay, with your mobile phone, your location, all that thing will be tracked. Okay, so we'll move on to the next slide. So it's 2:31. Hello, we'll move to the next slide. So down the line, it will be everything will be of massive scale, mind-boggling scale with unparalleled speeds. OK, and it has to handle heterogeneity. OK, heterogeneity means there are different protocols, different kinds of things and so on. OK, uh, different sensors, different actuators. So you have to convert from one technology to another technology and so on. So humans don't believe in uniform code. OK, they always have heterogeneity. OK, then we will have to make sure that this is secure. It's an so always an like an cat and mouse story here in case of security. OK, so always there is a catch up to be made. OK, and it has to be robust and reliable. OK, because lives will depend on it. Okay, whether it is engines, aircraft engines, whether it is medical implants, or whether it is an digital assistant, you name it. Okay, we'll move on to the next one. So what are the key building blocks? Okay, so IoT and connected devices. So that is one. Digital assistants, we'll look at it. Then cloud computing. Okay, big data analytics, blockchain, artificial intelligence, digital twin, autonomous vehicles. So we'll look at what is autonomous vehicle, additive manufacturing and 3D printing, robotics, and last but not the least, which is an hot field, is AR and VR. So we'll look at each of these building blocks. OK, and how IoT plays roles in this. OK, we'll move on to the next slide. OK, IoT and connected devices. OK, now how does it impact in manufacturing? In manufacturing, everything will be chit, like right from the warehouse, you will have everything um, on your plan board where you don't have to write anything. You will be having a dashboard where it will show you how much stock you have, what is the pipeline which is running. OK, is there a delay in the pipeline? What is the shipment which is going to come in? What is required at what time? How is your manpower scheduled to make sure that your current critical path is not affected? So these manufacturing, when I'm talking about manufacturing, it's not like building something small, it's huge. OK, the plans are huge. Okay, where this whole schedule, everything is tightly managed by softwares which will optimize on lot of areas. Okay, then shop floor monitoring, right? Okay, if you look at shop floors, like now suppose there is a paint job which has to be done and you want a correct temperature and correct humidity in that particular room to make sure that job gets completed on time. So the heaters, the humidifiers and all that will start running before the job is going to come into that particular area. Okay, so all that thing will be automated based on the plan which is created initially, and things will be lot uh, in a planned manner using digital software. Okay, AR VR. Now AR and VR, why do we require in automation? Okay, now suppose we want to build a new model of car. Okay, so AR. Okay, what is AR? AR is augmented reality. So the best example is suppose I buy a car which gives me an AR feature where I can do some maintenance on my own. Okay, so they will give me some mobile app or some glass or whatever. Okay, so if I wear that and I open the hood of the car and if I just look at the hood immediately in my glass, okay, so I will see the whatever parts are there under the hood of the car. At the same time, I'll see overlapping things saying that this is this, okay, this is this, okay. Then it will also talk to the uh, engine. It will talk to the data which is there in the car and which are sent to the central server, and it will tell me in the car saying that okay, the fuel level or sorry, the oil level is less. Okay, so and this is how you can change the oil level. It will show me which is the no, like the lid for the oil can and how to open it. So when I open it, it will show me that okay, whether it is open, then it will show me where to take and pour the liquid, how to pour it and so on. So you can have a lot of things guided. So that is AR, means you have an existing stuff. On top of that, you have an uh, whole reality built on top of it. Okay, so that is an augmented reality. Like suppose you have a room, you go to a room and it's an interior decorator's place. You go to a room, then on in that room they will virtually place sofas and all that stuff. So that is augmented reality. Now, what is virtual reality? Virtual reality is a totally new uh, thing which you see in the screen. Okay, like you must have seen some games where they take you onto a ride, right? In mine or some place, right? Okay, so that is a totally virtual reality. Like when you look from a virtual reality point of view, you might be in a jungle or you might be in some place and or you might be actually working on some part which is totally virtual. Okay, so that is VR. Okay, now automation will also play a huge role. So how this AR and VR will work is when nowadays the models which are created are in the computer, right? 3D sketch. So these will be all virtually created in the 3D model, and there will be designers who will be wearing specs in an empty room discussing and car model and how fuel lines are to be passed on, and there will be engineers also how like the wiring has to take place, what are the circuits which will go in, all the things, how the car seat has to be designed, okay, how will it look, they will turn the car around and so on. Okay, it's a virtual model. Okay, next is like transportation. In transportation, we talked about connected fleets, bus tracking. Okay, so wouldn't it be great? You will know when the bus is coming in. Okay, whether it is full, whether it has space in the bus and so on. Okay, optimization. Now, what is the route optimization? Okay, now suppose there is an two buses from the same vendor go from Mumbai to Goa, and half of them is filled in one bus, and in other half there is uh, other half filled in. Like one is taking people from Navi Mumbai and another is taking people from actual Mumbai, like from Borivali and these areas, and another is from Airoli, Ghansoli, Rabbali and these Navi Mumbai areas. Okay, so the owner finds that, okay, there are two buses which are half full, and the route from like there is a common place where both these will merge either through Vashi or wherever, and then it is a common route. So what he can do is he can put all the load in one bus and just take one bus ahead, right? Okay, so this is a very crude example in terms of where people are moving. But if it is goods, okay, this makes huge sense because the amount of goods which are moved in comparison to people, okay, it is huge. Okay, so that's how people optimize. Okay, now driver behavior and tracking for insurance we talked about. Car manufacturers. Okay, car manufacturers will be like in transportation, they will play a huge role because automated cars, okay, driverless cars. You look, if you look at Uber and all those things, they are heavy into this. They want to build driverless cars and so on. Okay, tire as a service. Now, what do we mean as a service? Okay, see, nowadays you buy a tire, you use it, and if it is worn out, you have to throw it away, right? Okay, so once you bought it, manufacturer doesn't have any headache of maintaining it. But if the tire was given to you as a service, okay, means you pay the guy who is giving the tire on the amount of number of rotations the tire has done. Okay, so in that case, the person who is giving you the tire will try to make sure that he builds a very good tire. Because he wants to make maximum money from that tire, right? He wants to give it out maximum number of times. Okay, he will put in sensors, he will do all sorts of things, and he will tell you whether you have used it very harshly, like, or whether, and all that stuff will be there, and how much turns it has taken place and everything, and you will get a bill. So if you don't like, you can return it back and you can take another tire. Okay, so these kinds of things will happen. Car as a service, okay, and so on. Self-driving cars, we know. MG Hector, you have already seen that. You can talk to the car and do a lot of things in the car. Okay. Now energy is smart meters we talked about, connected grid we talked about, dynamic charging we talked about, right? Okay. Retail. In-store customer experience. Okay. Like moment the customer enters the store, the system knows that the customer has entered. It can do facial recognition, it can do tracking on the device, and it can find out who has entered, what is his last history, what is he has bought, what is his interest are, and so on. So they can push products based on that. They can, whenever you go into that aisle, the aisle which is showing the ad in that aisle changes based on your preference, or it pops up on your mobile saying that there is a discount for this particular goods and so on. Okay, AR for the product. You take the product in hand and automatically it some genie comes up in the AR screen and it tells you and explains you and shows how to do things and so on. Okay, targeted offers based on past data, virtual shopping malls. Okay, now virtual shopping malls will be next in thing. So you don't have to physically go to a mall and you just wear an AR VR glass and just you can just roam around as if you are actually roaming around in the physical mall. Okay, but sitting at one place. Okay. Cities and buildings like while constructions. Okay, while constructing, they would like to know which equipment is at what place, who is using the equipment, what is the material present where, and so on. So these kinds of things are already present. Like if there is an hazard, okay, which are the people in that hazard area? Okay, are they qualified for that hazard area, and so on. Okay, so automated everything comes on the dashboard. Okay. Then HVAC is like an your centralized air conditioning unit, so those are controlled. Fire utilities. Okay, grow green. Like go green means like the your number of carbon emissions and carbon credits are counted. Okay, so all these are going to come in cities and buildings like garbage management, sewage treatment, healthcare, parking, digital guide map. Okay, and so on. Traffic congestion. Okay, camera, digital tickets, which you must have already seen, right? If you um like if you cross the white line and if there is a camera, you get a digital ticket. And I think some of you must have already got some tickets, right? So these things will happen. Okay, we'll move on to the next slide. Okay, in healthcare, okay, health records will be connected, implants, pacemakers will be continuously monitoring your status, and it will be sent to the central repository where it will um, take decisions and so on. Remote diagnostic we talked about. Vitals are nothing but your stats which are continuously taken from your body. Okay, remote surgery, AI based digital diagnostic which we talked about earlier. Supply chain, goods monitoring like temperature, shocks. Okay, just in time, like whether it's going to arrive in time. Pillage means somebody like it is opened and it is like lost because of some whether it is like water or frozen ice or somebody fell on it and so on. Theft, okay, real time location, okay, route optimization, load plan, fuel optimization. So all these are things which are going to happen in supply chain. So all these are self-explanatory words. Okay. Next is like agriculture and breeding. So here now how it will happen is right from bed preparation. Okay, your soil, what is the condition of the soil, all that thing will be captured. To store. Store means final product is harvested and it is stored. Okay, so monitoring of parameters, ingredients plan. Okay, what should go in that particular soil, means what should be given to the soil through the drip or whatever. Okay, or what is the schedule for the week, for the month and so on. So all this will be automatically done. Okay, harvesting with robots, cold storage, okay, delivery plan, driverless tractor. So all these are the areas. Okay, breeding is done like every animal will be tracked with a chip. The history of the animal, how much weight it has gained for the how much feed it has eaten and so on. Whether it has any history of illness, all that thing will be tracked. Okay, predictive maintenance. Now we know preventive maintenance, like the car manufacturer. Most of us have cars, and you must have seen that the car manufacturer tells you like after so many miles you have to do or kilometers you have to do, change the oil, change this, change that, and all that stuff. From preventive maintenance, things will move to predictive maintenance. Now, what is predictive maintenance? So there will be a lot of sensors in your car which will be continuously monitoring things inside your car, and if it starts vibrating, like any problem, it starts small and then it becomes big. So all that thing will be monitored and it will immediately tell you that okay, this is going off from your current limits. Okay, so you might require a maintenance of this or maintenance of that. So those things will come in. And that is very important in case of machineries like Boeing engines and so on, because you don't want to keep your flight on the ground. So if you know beforehand, like, okay, this part can go bad, it is started making noise or some vibration. So whenever there is a period in between flights, okay, the cooldown time, you can just fix it. Okay, you need not wait till the preventive maintenance schedule. Okay, so there are some good videos explaining about real world applications in IoT. So you can just look at those videos. Okay, so that's the link below. Okay, we'll move on to the next slide. Okay, IoT in warfare. Okay, so war doesn't always take place in battlefield. So this you have to remember. Okay, so it can be a biological warfare or it can be any kind of an warfare. So now, in case of a normal battlefield warfare, everything will be integrated. Okay, so right from your tanks to your equipments which are deployed to your personals which are deployed. Okay, so everything will be integrated. You will be continuously getting stats from where things are moving where, and these kinds of networks have to be very secure. Okay, so here a lot of IoT will be used where so most of the things might be unmanned. Okay, so which will be deployed. So like tracking, spying, then you can have mechanical mules, autonomous hunt. Like autonomous hunt is like you send out small drones or robots which just move around in city corners or where the battlefield, where the area is tight, and it will just locate based on infrared or any other technology and just it will kill. Okay. So these kinds of things will happen down the line. Okay, now in case so there are technologies where a missile, you must have seen Patriot or these kinds of missiles which go and hit other missiles, right? So nowadays what people do is there is Tomahawk missile which just cruises just above the ground and it can go to any place. So it can be deployed from a sea and it can go to any place and it can hit it an accuracy of an window of an house. Okay, so with GPS and terrain navigation. So those kinds of missiles are already present. Now to destroy those missiles, you have other kinds of missiles or laser technologies which have come in. So what people do is what these guys are doing is they are splitting the actual whole missile into multiple parts and they are sending it out. And when it is going near to the target, all of them come together in near real time. OK, and they form one bundle and they hit the target. OK, so these kinds of things are already in existence. OK, then there are you can deploy there are pipe like things which is you just deploy from the like from an airborne unit. You just fly over that area and just drop it. It will just go and sink, get it will sunk in the ground and just it will monitor. So if a particular car with a particular number or a particular vehicle is seen, it will continuously be watching, and if it sees that, it will just shoot out a missile and kill that particular vehicle. So these kinds of technologies are already present. Now warfare in non-battlefield, like people will do flooding of network with bots. Now why you will flood a network with bots? Okay, now everything is controlled by digital networks, right? Whether it is an electricity grid, water supply grid, financial grids. Okay, so if you want to bring a country down, but you want to get the resources of that country, right? You don't want to go and carpet bomb that country and destroy resources. Okay, so you want to get make that country weak and capture that country, right? So they will do all sorts of such things. They will attack on healthcare networks. They will try to use biological warfare. Okay, sabotage key installations and so on. So key office bearer security compromise using devices around the person. So that is also an warfare. So your devices like IoT devices can be compromised if you are in a key position. So you have to be very, very careful. Okay, we'll move on to the next slide. IoT and connected devices. So we have five senses, right? Smell, vision, touch, hear, and taste. Okay, so taste, there are sensors, but they are not much used. Okay, so they still rely on human taste. Okay, then for communication, you have Zigbee, LoRa, Sigfox. You must have already seen. Okay, SDR is an technology which is it's a software defined radio. So if you like you have your car key, right? If you press and beep, it will beep, right? And it will open your car. So that is nothing but an SDR signal, which is similar to your radio signals which are there. Okay, so this can be captured. So somebody can have an antenna and just capture your signal and then they can replay your signal and the car gets unlocked. Okay, and you can get it's a small thing which you can easily make it at home and you can just unlock anybody's car. You can just record anybody's car's beep and just open that car. Okay, so that is like a security risk actually. Okay, Bluetooth, Wi-Fi, IR, Ethernet. So these are the technologies which you must have seen, right? Then open source, okay, stuff like for image processing. So these are the some softwares which you can use like OpenCV, TensorFlow, Cresa. Okay, so all these are there, and image processing is going to be huge in these things. Why? Because they have to take decisions like whether it is like cutting a fruit in or fruit in an like what do you in a greenhouse, or whether it is like detecting an object. Okay, or whether it is identifying a number plate, you name it. Okay, so image recognition will be huge and AI in image recognition will be huge. So you can look at these. softwares for that. Okay, and below two are the links for security. One is IoT Security Foundation. So this works for IoT related stuff. Okay, this foundation. And the second one is an general. It's an open web application security project which works for web technologies and all these things like how to secure your deployments, how to secure your applications and so on. They also have a project for IoT. Okay, so these two places you will get a lot of details about security. Okay, we'll move on to the next slide. Digital assistant like Alexa, you must have already seen in that Google Assistant, Siri. Okay, so there will be intelligent bot with NLP. Okay, so what is NLP? NLP is nothing but natural language processing. So when we talk in terms of context. So whatever I have said in the earlier line that creates a context and the next line is based on that particular context. So a general tree has to be created and this requires a lot of AI. So there is huge amount of data which is collected by like IBM's Watson, Alexa, Google's Assistant. So this data is there on their server and it continuously learns. So it captures whatever you say and those trees are unanswered. Okay, so there will be some day where they will be starting in a much sophisticated way. Okay, so we'll find these bots speaking in much sophisticated way. Okay, connected homes like internet search, appliances, digital assistant, companions. You know what are digital companions? So like it can be a device which tracks your schedule, it tracks everything and it talks to you and says that okay, now you have to go to this meeting, now you have an appointment with this, okay, and so on. So that digital companion will actually take care of most of your stuff. It can be a device, it can be a robot. Okay, so the companion, so digital assistant will uh, get upgraded into companions down the line. Okay, in Japan, you have virtual pets. It might be a stone. Physically, it is a stone. Okay, but it becomes a virtual pet. And then there is an soft app on your mobile which is associated with that pet. So you have to feed the pet. You have to do like you have to take it out and all sorts of things. Okay, whatever you have to do with the pet. So there will be a continuous reminder in your app and so on. So and this is very hot in Japan, surprisingly. Okay, so we'll move on to the next slide. Cloud computing. You have three types of model in cloud computing. One is IaaS. IaaS is infrastructure as a service. Like this is like an you can take and compute like AWS instance. Okay, so that is nothing. You get a physical box which is in IaaS cloud. In AWS cloud and you can connect to it. So within seconds you get it like within 2-3 minutes. Okay, it gets created and you get it and you can just connect to it, right? PaaS is platform as a service. So if you look at PaaS, it is like in terms of electricity, IaaS can be like the people who generate electricity. PaaS can be termed as people who generate ICs. So you can build um, applications on top of, or you can build equipment on top of using electricity very fast, right? If you have ICs, you can build it very fast, right? Because ICs help you to. So same way, platform as a service, you have ready-made blocks. Like suppose it's for CRM, then you will have for customer definition, you will have for the opportunity and so on. So all that will be already available. You have to just put together and your application is ready. Software as a service is like you build the software once and you sell it to multiple people. So you might sell it to uh, company A. So they might have a link as abc.software.com and the same software is running for company B, then it will be b.software.com and so on. So the under the hood, it's the same software, but the data is separated into different database, but the core logic is the same and the server farm is still the same. Okay. So storage as a service like Gmail or wherever, like you have a lot of storage as a service. Okay, Dropbox and you name it. Okay, so we'll move on to the next one. So that's cloud computing. Okay, big data. Okay, big data is IoT is like series of creeks and rivers that feed into a big ocean of data, right? So you get a lot of IoT will send a lot of data and it will be collected. Now this data has to be analyzed, some information, some wisdom, all that thing has to be taken top of the data analytics period, right? So otherwise just capturing data is of no use. Okay, so there is a lot of data. It can come from agriculture smart devices to machinery, okay, asset monitoring, fleet tracking, you name it. Okay, so this creates a lot of data and you will require big data to analyze this. So that's why people say big data is hot, right? It is nothing but to analyze this kind of data. Okay, we'll move on to the next slide. Blockchain. What is blockchain? Blockchain is nothing but a distributed ledger. Means like if you generally if you do a transaction, it is written to a database. So somebody can go to the database and modify it. But if it is written to a ledger which is in multiple places, okay, you cannot go and modify in all the places, right? So it is like patthar ki lakir, means you have made a mark on the stone, okay, or okay. So it's an hub space decentralized or distributed ledgers. Like you can have it at one location or you can have distributed ledgers. Okay, so blockchain is helping combat security breaches in IoT technology because once written, it is very difficult for others to modify. It will be used in smart home, supply chain. See, suppose your fingerprint is there. Okay, you don't want somebody to go and tamper it, right? And replace it. So that fingerprint has to be stored in a very secure way, right? So those things will also use blockchain and blockchain will become very hot. Okay. Now, if you look at internet, there are multiple servers which are there available on the internet, which are there because of which you get internet. The same way this will come into picture. These servers, blockchain servers. Okay, and this will happen. Okay, we'll move on to the next slide. AI. Okay, IoT device as digital nervous system. Okay, but the brain is the AI. Okay, so AI, when added to IoT, it means that device can analyze data, make decisions, and act without involvement of humans because you need that, right? Suppose you have a digital surveillance system which you have put it across your perimeter of your house or across your plant. Okay, you don't want to sit and look at the cameras which are like, suppose it's a huge plant which is going into hundreds of acres and you want to make sure that your compound is secure. So you might have multiple cameras across the walls all over the place, right? Okay, so suppose if you look at BARC or any other place, right, where your reactor, so you might want to continuously monitor. You cannot keep a person looking at all these monitors continuously, right? So here all AI will come into picture. So moment if something comes in or moves around, okay, it will start to recognize and it will start taking action. Okay, so whether it's a dog moving around or whether it's in person, it has to identify and take decisions. And in near real time, it has to alert people or alert things such that it can countermeasure. Okay. Smart retail. Smart retail will use, like we talked about earlier, facial recognition, building automation, adjustment. Okay. Predictive maintenance. So all this will use AI. Okay. And ML models. Okay. Machine learning models. Okay. So we'll move on to the next one. What is digital twin? Okay, digital twin is like you create an virtual object which is resembling to the physical object. So suppose it's an oil well. So I take all the parameters of the oil well and give it to that digital twin. And based on the past data, I can know how the oil well will perform based on whatever the pressure it has, whatever the oil it is spewing out, the quality of oil it is spewing out. So based on this digital twin, I can take decisions. On this digital twin, I can do like analysis, like I can tweak a parameter and see what will happen and so on. So it's like a replica of a physical device where data scientists and IT pros run simulations. Okay, before it is built and deployed. Or sometimes it is actually for the physical thing which is already deployed. So if it is an heart, a digital twin of an heart, and they know there is an blockage here. So if we do bypass here, what's going to happen? So they will do it on the digital twin and look at the simulation and see, okay, that vessel, blood vessel, if we tap, then it doesn't do good. So let us try this one and so on. So all that thing is done on the digital twin. Mid-flight engine warnings. Okay, so all these lights up and the fail system works on the twin to find out what is the best solution and takes corrective action. So like these things will happen on the twin. So a lot of twins are getting built. Okay, and the twins will take care. Okay, fly by wire. So like if you look at the stealth bomber, its aerodynamic shape is nowhere near to make it fly on its own. It is continuously driven by avionics. Okay, so it continuously adjusted by avionics. So it is so here the digital twin plays a major role. Okay, so we'll move on to the next slide. Okay, it is 3.5, right? Okay, autonomous vehicle. So we have driverless cars, which is going to be the future. So cars is not a major threat, right? But it's driverless trucks. It's going to be huge, and there will be a lot of jobs lost in this area. Okay, driverless farm tractors. Okay, you just mark your farm area and just feed it in the tractor and just let the tractor loose. Okay, it will automatically go and plow the area. It will do whatever it is required to do. Okay, so those things will happen. In India, the farm sizes are very like not that big, but if you go to US, those farms are huge, like 200 acres and so on. So just if you take a drone and just fly it above it, it's like you just see a sea of one crop, like whether it's soya bean or corn or whatever. Okay, warehouse robots. So warehouse robots are these robots which work in the dark. Those warehouses don't have lights, but there are robots inside those warehouses. They continuously move the things based on what is required, and there will be a bay area. So where you feed in the order, and automatically these robots will go and get the goods. Okay, driverless Uber, which we talked about, flying pods. Okay, so you might have Amazon delivery through flying pods. Okay, or delivery drones. Okay, we'll move on to the next one. So these things are going to come in the future. Okay, additive manufacturing or 3D printing. Okay, so this is like IoT devices where custom shapes will be built, and with 50 billion of them around floating by 2030, there will be huge demand for 3D printing. So nowadays, chocolate 3D chocolate is already printed, right? So who knows? A house is also printed. Okay, so someday we might have we order something and a 3D printer in the house will just print it out. Okay, we'll move on to the next one. Robotics and automation. With AI and machine models, robotics will enter a new age where robots will take over most of the jobs. Okay, most of the jobs. Okay, automation will be a game changer with real-time feedback loop. Okay, and rapid progress in human emotion and AI will see robots behaving like humans. Okay, we'll move on to the next slide. AR VR we talked about. So this is a huge area where you will have and mind-boggling things happening. Okay, so right from training, like I can learn in how to assemble and disassemble an aircraft engine virtually sitting at home on a virtual model using a virtual tutor. Okay, so virtual exhibitions will be hot. Next areas, games will be hot. 3D model of the car, interior designing, all that will happen. Okay, we'll move on to the next one. Way forward, embrace the change. There is no other way. Okay, and move ahead. Resistance is futile because business and economy drivers are correctly placed. So when business and economy drivers are there, the change will happen. Okay, pick up the new technologies, adapt to the new way of life. Okay, we'll move on to the next one. Impact. Upcoming next 10 years are very crucial. Social, environmental, economical changes are evident. Okay, what is relevant now may not be relevant down the line, as most of them are disruptive implementation, which I explained you earlier. Okay, move on to the next slide. EU approach, they have a strong sense where digital sovereignty, like they want to make sure that AI can be trusted and all that thing. Okay, digital for strong and resilient economy. They want to make sure everything is proper, digital blockchain, digital identity, all that stuff. Digital for society, for planet. So they have a very good approach. Okay, we'll move on to the next slide. Long term impact, digital privacy will be a myth. Okay, your life will no longer be private. It will always leave digital footprints. Person existence will be dictated by digital existence. So your existence can be wiped out digitally. Okay, then you are no longer alive, but you are physically alive. Okay, so many devices on wireless on 5G, 6G, there will be heavy dosage of wireless. Like it will be like living in a kitchen microwave, because if you look at 5G, you will have antennas sitting on every um, pole on the road, which gives you light, right? So you need to have antennas so nearby. With most of the jobs picked up by automation and robots, life will be different. Okay, we'll move on to the next slide. Long-term impacts, warfare will happen on digital front and biological front. Most crime will be committed digitally. Humans will be having active presence in digital world than in the physical world. Okay, with robots acting like humanoids, who knows, laws might be passed where people will choose humanoids as life partners. Okay, it's not all gloomy, as better sense will prevail. Okay, okay. So moving on to the next slide, I think that's it. Okay, so we have, I think 310, right? Okay, any questions?
Yes, sir. There are some questions
Yeah.
from participants. What are the challenges to the widespread use of IoT?
Challenges means right now, first is like we talked about the bandwidth. Okay, so that is one, the data assimilation and processing I took. So those are the areas which will get impacted. So there are some technologies which have already come in, like cloud and all those things. But wherever there is an area which needs improvement, there are a lot of players who are coming and trying to pick up that area because they know that down the line this is going to be hot.
Okay, sir. So there is other question. What are the economic impact of the increased application of IoT?
So I told you, like economy, a lot of jobs will be lost to automation. Okay,
Yes, sir.
why it will be automated? Because there will be a lot of devices which will give sensor data. There will be other devices which will act like actuators, which will do the stuff which humans are doing. Okay, and things will move to digital, and because it moves to digital, there will be applications which will have AI based and so on. So that will impact jobs. So we have to upgrade our skill to go into next level.
Okay, sir. Sir, thank you, sir. Thank you
Yeah,
for your informative session, sir. You are cover all the session, whatever start from first session to up till now. You are just focus on the cloud, blockchain, and everything. So you are give the brief related to that, as well as with a real time example, we can understand the things more better way. So thank you very much, sir, to give us the time and give us such a nice session, sir. So we are looking
yeah.
forward you in the next session also. So I request you to uh, accept this token of appreciation from Information Technology Department of Shanankar Engineering College, sir. Request to
Thank you.
please accept this virtual
Yeah,
moment, sir.
thanks a lot. And it was a
Uh,
great pleasure giving this talk. Uh, so
Thank you, sir.
thanks a
We are
lot.
also looking forward you in the next future session, sir. Thank you a lot, sir.
Yeah,
Now
thanks.
I request participants to please fill the feedback. Our next session, that is a valedictory session, we will start at 4 o'clock. So please join that. Also request to fill the overall feedback form as well as the question paper. Thank you all.
So thank you. So I'll leave the meeting. Yeah.
Yes, sir.
Thank you.
Yes, sir. Thank you,
Yeah.
sir.
Thanks a lot. Yeah. Bye bye.